So we're going to first start with sum of a geometric series, which is S equals to A over 1 minus R. We did this yesterday. A over 1 minus R works when your first term is A and you're multiplying by R every time. So if I were to write this all out, it would be A plus AR squared plus AR cubed, and so on, where the general term would be A times R to the n power, or n minus 1 power. This is true provided the absolute value of R is less than 1, that it'll converge. Now let's generalize this. I would like us to rewrite this when A equals to 1 and R equals to x. So our first term is going to be 1, and our common multiplier is x. So plugging it in, I have A over 1 minus R is 1 over 1 minus x, and that's going to be 1 plus x squared plus x cubed, and so on until I get x to the n power. I'm going to write this out with summation notation. What would that look like? If I use x to the nth power as my general nth term, like I have over here. Now, if you wanted to use n equals to 1 as your beginning subscript here, you should know that this would have to be x to the n minus 1 power. Okay, now this right here, this is called a power series. It is one of many power series that we are going to work with, and all this is the same as our regular geometric series A over 1 minus R. Now the absolute value of R had to be less than 1, but since R is x, we say the absolute value of x is less than 1, which means x has to be between 1 and negative 1, and this is again what we call the interval of convergence, or IOC, which is negative 1 to 1. The sum from n equals 0 to infinity of c sub n times x to the n power, where c is going to be some constant, so it'll be c sub 0 plus c sub 1 times x plus c sub 2 times x squared plus c sub 3 times x cubed, plus so on all the way to c sub n times x to the n, and so on. This is what we call a power series centered at x equals to 0. Now I'm also going to write up another form for power series, and this is going to be very similar, and this is going to be centered not at x equals to 0, but at some number x equals to a. So I'm going to modify this a little bit. Instead of my x, I'm going to write in an x minus a, and everything else will be the same. So this here is a power series centered at x equals to a. I'm going to have us use that first power series that I wrote up at the beginning, 1 over 1 minus x, which is our first term 1, multiplying by x every time. I want us to use this and see if we can come up with more power series. I want us to write 1 over 1 plus x as a series. Now let's think about this. If this fits our form, a over 1 minus r, what is our first term? And what is our r? What are we multiplying by? Well, it's a 1 plus x, so that means r has to be negative x. So what would that be as a series? You start with 1, you multiply by x every time. So 1 times a negative x times another negative x times another negative x. So we should have negative x of those to what power? If we write the nth power, then that means this would be starting at 0, and that would be negative x to the n. Now I would like to clean this up a little bit. I can write this out as 1 minus x plus x squared minus x cubed plus plus. Now I'm going to rewrite this and split it up and make it negative 1 to the n times x to the n. Now why do I want you to do it like that? That way it fits the form of what we have up here above, so you can see the constant separate from the x terms. And I also want us to think about the IOC. Well, r happens to be the absolute value of x, so that must be less than 1 to converge. Well, the absolute value of negative x is the same, so it's still between 1 and negative 1. Let's try another one. We can use any previous series that we've already figured out to help us with this. Thinking of this as matching up with a over 1 minus r, what is our first term here? X. And what are we multiplying by every time? A negative x. So if we have x, the next term is negative x squared, then positive x cubed, then negative x to the fourth, and so on. Again, notice the alternating series. So I want to have negative 1 to the n, x to the n. So it's actually just like the one we did above here, except what? We multiplied everything by an extra x. You could even have thought of this as x times 1 over 1 plus x, and taken every single term up above here in example 1 and increased it by an x. So let's also write this out in summation notation. And all that is taking that general nth term and copying it down and putting a little sigma in front of it and telling me where n starts. Our IOC, we have to have r, absolute value of r, being less than 1. So in this case, between 1 and negative 1, still the same. Let's try another one. 1 over 1 minus 2x. Do you guys have that? All right, first term is 1, multiplying by 2x every time. So as a general form, we can say that it's 2x to the n power. And when you write it out in summation notation, we can use this and write 2 to the n, x to the n, with n starting at 0. Now our IOC here, our multiplier was r. R has to be less than 1. So that means absolute value of 2x must be less than 1. So x must be between 1/2 and negative 1/2. Let's try another one. How about 1 over 1 minus x squared? Remember, this matches up with a over 1 minus r. So 1 plus, we're multiplying by x squared. Then we multiply by another x squared. And we multiply by another x squared. This is actually 1 plus x squared plus x to the fourth plus x to the sixth, and so on. What is our pattern? We actually have x squared to the n power, so our pattern is x to the 2n power. Don't forget your plus dot dot dots at the end. And in summation notation, this would be this. Let's think about our IOC. R happens to be x squared, so the absolute value of r has to be less than 1. So that means x squared is between 1 and negative 1. Now, try to be a little bit careful here. This is now algebra. X squared is always going to be some positive number, so I really don't have to worry about that half of it. I have to worry about x squared being less than 1. That would actually mean x has to be between 1 and negative 1. If you're going to struggle with this, you might want to subtract it, put it on the other side, factor, and do your little test interval. And you'll notice that you actually have to be between here. So your IOC here is between negative 1 and 1. We're going to do a couple more. So let's try 1 over x. This is now a little bit more challenging. I need to think of this as a over 1 minus r. Now I don't have a 1 minus r on the bottom, so we need to rewrite this. How can we make this 1 minus something? So think about it for a second. Pause if you need to before I give away the answer. I know many of you guys are probably thinking 1 plus x minus 1, because the 1 and the minus 1 will cancel out. But remember, we want it to be a over 1 minus r, so I'm going to write this out as minus a negative x minus 1. I know it looks a little bit tricky, but that's what I want us to use. I do not want you to use 1 over 1 minus 1 minus x. So I need you guys to remember to do this instead. R happens to equal negative of x minus 1. So our series is going to be 1 minus x minus 1 plus x minus 1 squared minus x minus 1 cubed, and so on. Now what is our general nth term going to be? We're going to have negative 1 to the n power, and then x minus 1 to the n power. So in summation notation form, this is what we have. So the last thing I need to do is find our interval of convergence. Remember, the absolute value of r has to be less than 1. So the absolute value of negative x minus 1 must be less than 1. So x minus 1 is between 1 and negative 1. X is between 2 and 0. Notice the IOC this time is 0 to 2. What's in the middle in between 0 and 2? 1. That's why it's centered at 1, and you see the 1 right here in our series. One last one to do. What would 3 over x be? Well, we could think of this as 3 times 1 over x. and we figured out what 1 over x is up here above. So it's going to be 3 times 1 minus x minus 1 plus x minus 2 squared minus x minus 1 cubed, and so on. Multiplying the 3 in, I have a 3 minus 3 times x minus 1 plus 3 times x minus 2 squared minus 3 times x minus 1 cubed. And then we have here 3 times negative 1 to the n, x minus 1 to the n. Now what's our IOC? Did our common multiplier change? No, we were still multiplying by x minus 1, a negative x minus 1 every time. So our IOC stays the same. It does not get multiplied by 3 or divided by 3. It's still between 0 and 2.